Hello, this is Shubhra Kanti Karmaker, and I want to demonstrate you the computer network sessional on distance vector routing. Well, in distance vector routing is one of the major classes of unicast routing protocols using partial information for route. We will simulate a virtual network with 5 routers and 9 networks. And in this configuration, we will virtually simulate the network layer implementation. That is, we can make the network up or down or the router up or down, and we will see the corresponding changes in the networks and in the routing table. So the network will be the topology. For example, in this picture, we can see there are 5 routers. Router 1 is connected to router 2 is connected to router 4 or router 3, and these are actually networks. So this is network 1, it is connected to router 1, network 2 is also connected to router 1. So in a text file, we will give the output in this format, and the assignment or the project will demonstrate the behavior of the will actually simulate the behavior of the network layer. So let us go to the demonstration. Here is the code. I am running the code. So this is the sample GUI. We will select the input file from the JFile chooser input.txt. This is the file, and we'll select the time interval for 2 milliseconds, and then we'll press the start button. Okay, so we have plenty of GUIs, one GUI for each network and also one GUI for each router. So we can see that there are 9 GUI for networks and 5 GUI for the routers, because the network has 9 networks and 5 routers. Okay, now let's look at a router. What a router does, it has up and down button and also routing table, and the table actually denotes the routing information or stores the routing information. For example, for router 1, this router 1, if if someone wants from network 1 or from router 1, if someone wants to go to network 9, then the router he should choose is router 2. So here network 9 says router, the next hop is router 2 and the hop count is 3. So from here the packet will go to router 2, and from there the router will go to router number 4, and it will take actually 3 hops. Okay, now let's see about a network, what a network does. Here is network 1, that is uh, this is network 1, and this is the GUI for network 1, and also we see the GUI for network 9. So this is the GUI for network 9. From the picture we can see that from 1 to 9 this is the path, and now all the routers are okay, all the networks are okay. So if we ping from network 1 to network 9, then the ping should be successful. So this is network 1, destination ID is network 9, and we do the ping operation, and we see that the acknowledgement has reached to source network 1, so the ping was successful. Again we can do the traceroute operation, and again this is successful as usual. Now what we can do is we can make the network 9 down, so that network 1 cannot find network 9, so as the network 9 is down. So now network 9 is down, so it is dead. So we'll again try to ping from network 1 to network 9, and this time this ping should fail. So we are pinging, so waiting for reply, processing, but hopefully there is no reply. So destination network unreachable. So network 9 is not accessible. If we again make network 9 up, so again we can try the ping, and this time the ping should be successful. So not yet successful because the router takes some time to update the routing table. We can try again. So this time this is successful. Okay, so the network down and up operation are working absolutely correctly. Now let's look at the routing tables. So we are looking at routing table 3, router 3. Here is a router 3. We can see that if this router is down, no one from this portion can connect to the networks of this portion. So router 3 is the junction. If we make let us first look at the router 1 routing table of router 1. Router 1 says that if we want to go to network 5, then we have to, the next hop is 2. So this is the way, and it has to pass through router 3. So if router 3 is down, then network 1 cannot ping 4, 5, 6 or 7. This is usually the case. So we are going to make router 3 down. So router 3 is up, now we make it down. So in the same way, router 1 will change its routing table. It should update. It is still showing that it can access 4, 5, 6 or 7. Now it shows that the hop count is 16, which is the maximum count, which means this is infinity. So now router 1 says that it cannot route any packets to network 4, 5, 6 or 7. If we try to ping from a network 1 to any of the networks of 4, 5, 6, 7, it will show that the ping is not successful. So processing ping request and not successful. But it can ping any network of 1, 2, 3, 8 or 9. For example, I will ping 8. So ping, this is successful because router 2 is okay, router 4 is okay. But if I press if I ping for network 7, then it should show that it is not successful because router 3 is down. If router 3 is made up again, then the situation will change. The routing tables will change. So I am making router 3 up, and again I am going to routing table of router 1, and now it shows that it can access 4, 5, 6 or 7. So if we now ping from network 1 to, for example, network 7, this ping should be successful, and it is showing that yes, the ping is successful. So that's all about this project. Thank you very much.